Hey guys, so today what we're going to do is talk about quadratic functions and their key features. Now, key features are the important things that you need to be able to find when working with quadratic functions. So the first thing we have is at the bottom here, we want to know what the parent function is. Now, the parent function is what the function looks like without any changes made. And for a quadratic, we're going to have f of x is equal to x squared. That's the same thing as saying y equals x squared. And the name of the shape of this graph, this is called a parabola. These are just some important things to know in case you are asked about the parabola so you know what you're talking about and what the parent function is. Okay, so we have various vocabulary words here on this piece of notes, and these represent different key features of quadratic functions. So the first one I'm going to talk about is actually the vertex, and I'm going to be color coding. So the vertex is the place, is the point where the parabola turns around. Okay? Every single parabola has one. So on graph number 1, our vertex is right here, and that point is 0, -3. And we always try to label our points when we have them. And we're going to pretend these have arrows on the end, just as an FYI. Okay, so here for graph number 2, our vertex is here, and this is 0, +3. Remember, your x comes first, y comes second. And something that's also important to know is your vertex can be represented in the terms of h, k, where h is the x and k is the y. That will become more important when we get to vertex form. Graph number 3, our vertex is here, and that is -1, 0. And finally, graph number 4, our vertex is right here at 1, 1. So that is the first thing that we need to be able to do. Now, the thing is about the vertex, you can actually find other pieces of information from this. So for example, we have our minimum and maximum. So our minimum and maximum is our highest or lowest y value for the parabola. This is our k. So for number 1, our minimum is -3. For number 2, our maximum is 3. For number 3, our maximum is 0. And for our 4, our minimum is 1. And you'll notice that the maximums are the parabolas that look like frowns. They have a highest point, and the minimums go with the parabolas that look like smiles. They point up. Smiles are called concave up. Frowns are concave down. Remember that because down rhymes with frown. So another thing that we can get directly from the vertex is our axis or line of symmetry. This is going to be our vertical line that passes through the vertex. This cuts the graph in half. Remember, symmetry just means that it's the same on both sides, like a butterfly or a snowflake. Human face is roughly symmetrical. And those are always going to be represented by x equals h. And the h, of course, also comes from the vertex. So for number 1, I'm going to represent this with a blue dashed line. X equals 0. Number 2 is also x equals 0. Number 3 is going to be x equals -1. And number 4 is going to be x equals 1. So those are the easiest ones we can do. We can get all of those pieces of information just by knowing how to find the vertex. And that's why it's very important to know how to do that. Now the other things we need to know how to find are symmetric points. Symmetric points are 2 points on the parabola with the same y value. They are equal distance from the axis of symmetry. So for example, on number 1, we have these ones right here. And we're going to keep in mind that we're looking for pretty points, points that go directly through the grid lines. They're the easiest ones to graph. So this one's -3, 4, and this one is 3, 4. Over here, number 2, this is -3, -4, and this is 3, 4. Number 3, here's some pretty points. This one is going to be 1, 2, -4. And this one is going to be -1, 2, -3, -4. Those are our symmetric points. Now the last set of key features we have is over here in this box right here. These are our roots, zeros, solutions, x-intercepts. These are all synonyms for the same place. For roots, solutions, and zeros, they are the x value of the x-intercept. Which is where parabola crosses the x-axis. Let's say touches. So on graph number 1, we have them here. So our x-intercepts are -2, 0, and 2, 0. So that means our solutions are -2 and +2. Same for number 2. Again, the solutions are 2 and -2. On number 3, the only place where it touches or crosses is here at the vertex. So that's going to be -1, 0. And the only solution we have is -1. And finally, we have number 4. Notice how number 4 does not cross the x-axis at all. It does not touch it or cross it. So this is going to have no real solutions. Now the last thing I want to talk about in regards to the functions here is the domain and range. Domain and range is really important for all of our graphs. So the domain and range for these will vary depending on what you have in front of you. All 4 of my graphs have arrows at the end because I'm assuming that they do. That's what I wanted them to have, since they do not have defined endpoints and they are not a real-world situation. So for non-real world situations and graphs without defined endpoints, your domain will always be all real numbers. All real numbers. Okay. ARN, all real numbers. And I'm going to abbreviate it ARN since it is hard to fit that. Now, our range will differ because notice how even though it will go in the left and right direction forever and ever and ever, it does not go up and down forever and ever. That's why we have a minimum or a maximum. So for number 1, our lowest point is -3, and all of our y's are greater than that. Same thing, number 2, our highest point is 3, and all of our y's are smaller than that. For number 3, all of our y's are smaller or equal to our 0. And for number 4, all of our y's are bigger than 1. And looking at this, I realized that I forgot to mark some symmetric points for graph number 4. So here we go. There's some symmetric points. So that's 2, 2, and 2, 0. Sorry, 0, 2. Okay, so that's all the key features. I know it looks like a lot. It is a lot of information, but these are things you need to know in order to solve a quadratic function at any point. We have 3 different ways that quadratic functions can be represented. One is vertex form. So the way that looks is going to be y equals a times x minus h squared plus k, where x and h are the coordinates from the vertex. Standard form is y, or f of x, is equal to a x squared plus bx plus c. C is our constant. It will also be our y-intercept. C is always the y-intercept. And finally, we have factored form, which is going to be f of x or y, I'm going to use y for this one, is equal to a x minus r1, x minus r2, where r are the roots. So that's basically all there is to it on the quadratic functions key features. Next time we'll talk about how to take the vertex and plug it into vertex form, how to get a third point. Remember, for quadratic functions, we need 3 points to define a function. So we need to make sure we know how to do that. That's why we care about symmetric points, roots, and vertices. So that's everything for here. If you have any questions, feel free to go ahead and leave them in the comments below. Thanks.